Hello, everybody, and welcome to the Streaming Video Alliance's October webinar called Understanding Open Caching. We definitely appreciate all of you taking the time out of your day to come to this webinar and listen to this really exciting topic about, what we consider to be kind of next generation streaming architecture. I'm sure you'll find this very informative and very useful. A couple of housekeeping items. We will be recording this session. So if you have a colleague or a friend who was unable to attend today, it's not a problem. You'll get a notification that the recording is available a little bit later this afternoon. And the second thing is, obviously, we want this to be an interactive session. So if you have questions, please post them in the questions panel. That should be available on your webinar control panel that's visible when you're during this webinar. And what we'll try to do is we're going to try to take a little bit of an intermission and answer some questions during the middle of the slide presentations. And then at the end, we'll return back to the questions and see if anybody else has any more that we can address as well. And of course, if you have questions after the fact, you can always email the panelists who I will introduce shortly. And they can get back to you with information regarding your question as well. All right. Now, just to introduce ourselves, so you have a little face with the voice. My name is Jason Tebow. I'm on the far right-hand side. I am the Executive Director of the Streaming Video Alliance. It is my pleasure to have these two gentlemen with me today. Dan Sahar, he is the co-founder and VP of Product Marketing for Qwilt. He is one of the Open Caching Working Group chairs. And our second is Eric Klein, who is the Director of Infrastructure Delivery for BAMTECH Media. He is the other Open Caching Working Group chair. And these guys are fantastic. They're polished presenters. They've got great slides, and they know open caching, like nobody else. So it'll be great to hear them talk about the subject and really get into, what it means to have open caching as part of your delivery strategy. All right, now before we do that, what I want to do is I got a little PSA about the Streaming Video Alliance. So you may not be aware of what our organization does or why we're putting on this webinar to explain what open caching is, or even why an organization out in the industry would be working on open caching. So I want to explain a little bit about what the Streaming Video Alliance is before we jump into the presentation itself. So just to give you a little bit of a background, the Streaming Video Alliance is a global consortium of companies that have come together to build best practices, specifications, guidelines, functional requirements, addressing a lot of the challenges in today's streaming landscape. So ultimately what we're after is promoting online video. We want online video to be adopted faster. We want it to be adopted by more people. And in order to do that, we need to help the industry solve a lot of the problems and challenges with things like scaling, with things like caching, with things like delivery and measurement and quality of experience. We need to help the industry solve these problems. And we do that by bringing together a host of different companies across the video ecosystem. So we have network operators, we have service providers, we have content owners, we have technology companies. And you can see here on the screen, these are some of the data points that we use to promote the alliance to the industry. You can see that we've got about 59 member companies. We've had a lot of growth. When we were founded, it's a fairly young organization, but growing rapidly. And the cool thing is that we have a lot of active working groups. So we have working groups around scaling. We have working groups around open caching, around geo. We have around privacy and protection. So we have a lot of active working groups that are focused in on some of the most critical challenges that the industry is facing. Now, to give you a little sense of who some of our members are, our membership is broken down into 3 levels. We have what are called sponsor members, and these are our board members. And so you can see the logos on the screen. We've got companies like Amazon and BAMTECH Media, Qwilt, Sky, Nokia. So we have a lot of big names in the streaming space and in the caching space. Our next level of membership is what we call our principal members, and these represent companies that are taking an active role in solving the problem. So they are in our working groups, collaborating with their fellow engineers, and in some cases that means they're competitive engineers to solve these problems. And you can see again that the list is very broad when it comes to the video ecosystem. You know, we have companies from Viacom to Dolby to Adobe to Erdeto and NextGuard and nice people that work in Conviva and Sodexis. We've got companies sort of all over the map, and that's exactly what we want, because without proper representation from the entire ecosystem, it's very hard to solve these challenges like open caching. And our last level of membership is what we call supporting members. And these are companies that they really want to be involved, but they don't have the resources. You know, in other words, they don't have the time or the people to really dig into the working group sessions and contribute to documents, but they want to remain up to speed with what's happening. They want to be connected to the discussion. And so you can see here that, again, we have a good cross-section of companies who are supporting members. You know, everybody from CenturyLink to Sienna to Verimatrix to Edgeware. You know, really just, again, it really depends on what a company is willing and able to do that determines their level of membership. All right, with that said, I am going to turn this conversation over to our esteemed presenters, Dan Sahar and Eric Klein, who are going to talk to you about open caching, and again, what it is, what it means to you, and you know how this might really revolutionize the way that that video is streamed over the internet. Take it away, guys.
Thanks, JT. So hello, everyone. This is Dan speaking right now. So we thought before we dive into open caching, what it is and how it works, we thought that maybe we can start with you, Eric, and perhaps you can give the audience a little bit of background about BAMTECH, what it does. Like, I'm not sure everybody listening is familiar with your organization, and then maybe within that role as BAM, what are the key problems that BAM is trying to solve, and you specifically in your position in the company? What's keeping you up at night as like one of the largest streamers in the world?
Certainly. Thanks, Dan. So to give a brief background on BAMTECH Media, we're formerly known as Major League Baseball Advanced Media, and are now a standalone organization that is invested in by Disney and in partnership with Disney. There's a great deal of media that we tend to deliver primarily focused around live media, so we're talking about MLB, NHL, Major League Soccer, and then we also work with quite a lot of partners on kind of the more traditional linear over-the-top playback, as well as video on-demand content. You could check out our website for a whole host of partners that we leverage. But really the question that it comes down to for me is, what problems do I face as the one that's kind of in charge of the content delivery strategy for our organization? How do we get content from point A to point B, from our data centers and from our environments out to end users on mobile devices everywhere, on set-top boxes of all different kinds and different varieties, and on different types of platforms, you know, gaming consoles all the way down to smart TVs. And really, the challenge that we have from the delivery side is that while we work with quite a few content delivery networks as partners, they only go so far. There's only so many details and challenges, insight that we can gain from using a content delivery network down to an ISP level, right? Ultimately, that last mile of delivery, that last little bit of delivery, is something that's out of our control and out of the content delivery network's control. And being able to have a deeper reach into those internet service provider networks, being able to gather richer insight into what is going on those internet service provider networks, and then in addition to that, being able to more thoughtfully inform the caching decisions and the content treatment on those networks for how our content is being handled from a delivery mechanism standpoint is really important to helping us lower our rebuffer rates, to improve our performance overall for our customers, and to ensure that we have a smooth, stable, consistent, and high quality experience.
Thanks, Eric. So following up to the description that Eric just gave, I thought it would be good to take a look at the way that content is typically being delivered and streamed around the internet today, and the evolution of that that we're trying to achieve with open caching. So as you can see, this is there's three tiers in this diagram in front of you. We have the publishers at the top, which is the entity that Eric is ultimately representing here, and then we have for the past 20 years or so, we've had content delivery networks, or CDNs, that typically are able to bring the content closer to where the consumers are, and normally would have tens or hundreds of thousands of servers that are distributed around the globe. In some cases, these would be in IX locations, where they're heavily reliant on peering when they access the service provider network. And in other cases, they would actually have servers inside the ISP networks, like on the provider edge of the network. So like typically connected to where transit would be connected to the service provider network, but definitely not in the last mile of that network. And this is the model that's been used across the internet, I think, both for websites, but also obviously for streaming content. What we've been set to achieve is kind of like an evolution of this architecture, leveraging a new content delivery layer that we call open caching. And the idea is that we basically want to leverage infrastructure that either already exists or is about to be created inside the service provider network and service provider infrastructure. This would typically be common compute infrastructure. There's many ISPs around the world that are building or already have built compute infrastructure inside their network. So it's no longer just routers. Now you have a lot of micro POPs or edge clouds or edge compute infrastructures that are being built. And on top of this new infrastructure, we're proposing a new layer that we call open caching. And as you can see in this diagram, it would be a combination of multiple open caching systems, or OCS, shown in this slide, that are installed within the ISP network. So between many different ISPs, you're able to achieve a very deep penetration, low latency framework that now can be leveraged by publishers and by CDNs alike. So the closer, obviously, you get to the end user, the lower the latency that you're able to achieve. And by doing that, you're hitting, at least on one of the goals that Eric mentioned above, which is better quality. You're closer to the user. It means that you're able to overcome or sidestep potential bottlenecks on the transmission path from the server to the user. And additionally, because of the very low latency from that location to the user, which typically would measure in the 20 milliseconds or lower latency, you're also able to get higher TCP window sizes and just like much better bandwidth, which would ultimately improve the streaming quality to the users. So the way to achieve that is to establish a framework that allows the CDNs, the existing methods to distribute the content, to actually make use of this layer. And this is what we set out to design. This is the architecture that we've built. It's essentially revolving around these dotted green arrows. And open caching have created a set of APIs that enables CDNs and publishers alike. So this can be a publisher that has their own CDNs or commercial CDNs to basically have reach in hard to reach places. So this can be an ISP in an area of the world where there's no good CDN coverage, or it can actually be deeper coverage in an area of the world where CDNs do have coverage, but not at the latency that can be achieved with this open caching layer. Ultimately, the delivery will be performed from multiple open caching nodes. So each one of these OCSs is actually composed of many, many discrete nodes that are deployed like very close to where the consumers are. Now, the objective in doing this is we see four objectives, and I think Eric outlined them before. So the first and foremost is quality. Ultimately, every content provider that is out there is trying to achieve a just like a quality that is at least on par to what you're able to get in your TV today, like with standard broadcast. And not only achieve that level, but also take that to the next step where we want to have 4K broadcast, 360, and VR videos that are just, you stream them, it never buffers, there's never an issue of quality in them. And this is a mechanism to do that. The second objective is that by bringing the content closer to where the consumers are, it means that there's less repeat consumption of content on our internet pipes. So instead of having to transmit a very large file, and 4K videos can be extremely large, instead of having to transmit them across the entire path, you can actually do that only from the last mile, from a few miles away from where the users are. And by doing that, the entire internet infrastructure is just scaled in a more efficient manner. I mentioned reach, which is there's no one CDN in the world today that is the best everywhere in the world. Every CDN has black holes or areas where the reach is not optimal, and this is obviously both closer and because it's more distributed, this layer can be deployed in ISPs where there's not necessarily good CDN coverage today. And lastly, as Eric mentioned, because this is within the ISP network, it has the potential to actually provide very good insights, both network insights that do not exist today, but also streaming insights from a very close location to where the users are. So at this point, we want to dive. JT, maybe let's see if there's some questions from the audience.
Actually, that's fantastic stopping point. So I do have a couple of questions. The first is somebody in the audience asked, how do we make sure that all the users are seeing the same video at the same time? For example, if two people are watching an NFL game, we don't want them to be at different points in the data stream. Is that a question you guys want to answer now, or do you want to wait till the end to answer that one?
Sure. Eric, do you want to cover that?
Yeah, I can talk about that a little bit. I mean, it's definitely a challenge today. There's a lot of different ways that people are looking at handling that type of a challenge. It's something within the group that I think we're beginning to look at as a potential option. I think it's less related to what we're doing within the Open Caching Working Group directly, but talking from our experience and how we handle things, our goal is to keep caching time very low, lower the size of the object as low as possible, and also make sure that the buffer is as limited as possible in order to really improve that time to live, if you will, get as close to live as possible. There are a lot of things that are being done in the space around varying protocols across different backbones if you're dealing with different CDNs or ISPs, looking at things like Qwilt and various other TCP-based optimizations that help improve that performance. Then there are also other providers that are looking at synchronization in the space down at the content delivery network layer. It's not something. It's not an area we've particularly explored yet as part of the open caching working group, but it is something that consistently does come up as an area of focus. And there is a new group within the Streaming Video Alliance focused on live streaming that is making this one of their major charter initiatives. And I have a feeling that that group, as well as our group together, are going to make some real strong improvements in that area over the next year or so.
Great answer, great answer. The second question I have goes back a little bit to what Dan was talking about with the two graphs and the two illustrations and sort of the differences between the way content is delivered now and in an open caching environment. What are the components of an open caching architecture? So for example, what does a service provider like Comcast or Verizon have to implement in order to take advantage of this?
Okay, this is actually the next slide. This is a good question, as you say, because we have a slide prepared exactly for that. The architecture that we've created for open caching, there's at like very high level, there's four main constituents here in this architecture. So starting from left to right at the circles at the top, we can see that the user, obviously, they start the entire process of watching a video. Inside the ISP network, you would have multiple elements known as OCNs, which is open caching nodes, which is, you could think of them as caches that, or caching software that you can install inside, running on top of any server inside your network. And basically, a typical ISP can have tens to thousands of these types of servers distributed within their network infrastructure. Now, the control plane function that coordinates the delegation of content to these OCNs is called OCC. It's Open Cache Controller. Think of that as the layer that acts as the API between the delegating entity, which is the final component, which is the CDN here in this diagram, and the OCN. So if a typical CDN wishes to delegate the delivery of content to an open caching system, they would have to go through an OCC in order to do that. So the API for delegation is taking place between the OCC and the CDN. And the OCC is, think of it as the parent or the responsible entity for a collection of OCNs. Now, an ISP would typically have to deploy multiple OCNs in their network, and one or more OCCs that will be able to control those OCNs. The OCC may be deployed inside the network, or it could also be deployed in the cloud, because it's not handling the actual data traffic. It's only handling the control plane traffic, and both options are viable from the service provider's perspective. Now, in this diagram, this is like a very high-level call flow, which shows the key elements in the delegation of traffic, and then what occurs after that. So I'm gonna go through it at a fairly high level. If people in the audience want to drill down to individual components, you feel free to shoot Eric or I direct questions on that, and we should be able to answer that. So we've so far defined four main interfaces that encompass open caching. One note is that a lot of the work that we've done is also leveraging work that was done in the IETF by the CDNI working group. But we've actually we've discovered areas where we felt that there was additional requirements that needed to be done, and this is what we've done inside the SVA. So the first interface is called service provisioning. This is basically the bootstrap process of the entire open caching delegation process. In this phase, an ISP with a set of resources, a set of OCN resources, would have to decide on what is the edge resource allocation, i.e. how much storage, how much bandwidth it's actually being able to provide for delegating entities. And it creates a delivery service with an SLA between between the ISP's open caching system and the delegating CDN. So think of this like a handshake between the delegating entity, which is the CDN, and the ISP. Once that is created, and there is now a delivery service that is online and let's call it ready to go, the actual delegation of the content is taking place. This is known as request routing. What we've tackled here is because a lot of content is now moving towards HTTPS, we've made sure that request routing is actually able to address both HTTP and HTTPS use cases. And today we've spec'd out two methods to perform request routing. One is to use HTTPS redirect, or 302 redirects as they're known. And the next is to actually use DNS CNAME delegation. In the POC that we're going to discuss, we actually tested the redirect, but DNS CNAME delegation is also one of the methods that some CDNs would prefer to use. So by request routing, what is actually taking place is a CDN is receiving a request for the content from the user, and instead of delivering that content by itself from its own caches, it's actually delegating that to the open caching system and ultimately to an individual OCN in that network. Now, once the request is actually being handled by an open caching system, obviously you have to log that transaction for multiple purposes, both for troubleshooting but also for billing perspective. And the method that we've chosen to do that is that the OCC acts as an aggregation point for the logs. So that means that a CDN doesn't have to interact directly with tens or hundreds of thousands of various OCNs deployed in many ISPs. CDN only works directly with the OCC. After the OCC collects those logs, it's able to stream them to the CDN. And then the last interface that we just a couple of months ago concluded is the content management interface. And this allows the CDN to actually invalidate the content or purge it. So if in cases where there's a bad encode or for various other reasons, content has to be taken down from the OCNs, you're able to do that with this interface. And also to do various content management actions like pre-population of content. So let's say there's an upcoming episode of Game of Thrones or like a very popular series, which you know as a CDN is going to be very popular in your caches. You're able to push that content and pre-populate it ahead of time so that the caches are hot before the event actually takes place. So this is the high-level architecture that we've created like over the last almost 2 years, I guess, for open caching. Eric, do you have any insights to give on the various interfaces?
Yeah, I think it's probably best instead of kind of going through deeply and talking about all the different interfaces, because there are specifications available for these on the SVA's website. I think it's probably better just kind of give a brief sample of kind of a real-world use case for each of them and run through them quickly. So in the service provisioning standpoint, we really tried to think about how can a CDN and an ISP or a CDN and an open caching environment talk together, right? What is the ways that those two can interface and engage and share data back and forth, and what's the requirements and responsibilities there? And I really just want to kind of point to how detailed we've been going. When we talk about the SLA for content delegation, in one of the working group sessions, that was I think it was an hour and a half conversation about trying to figure out like what part of the contract each team required in order to satisfy different aspects of it. And what's really nice about those conversations are we're looking at things from both a content delivery network as it exists today with a third-party provider, as well as individuals that create their own network, an internet service provider viewpoint, as well as content provider viewpoints. So being a content provider, I get to have involvement within that room to push our viewpoint and push our needs to effectively our two different providers, right? The two different vendors, the CDN and ultimately the ISP. In the request routing standpoint, Dan, you brought up HTTP, HTTPS redirect. I think it's important to mention too that we're constantly revising these specs, right? They live and they breathe, and being part of the group is that we're always updating things. And in the case of HTTP, HTTPS, what was in place for CDNI, which, as you had mentioned, Dan, we borrowed a lot from, what was in place about 2 years ago when the request routing spec, which was the first spec that was completed, kind of came to fruition. It's evolved since then, and CDNI now has additional suggestions and ideas, and we've had some additional research that we're doing into the space around different ways to handle HTTPS delegation. Previously, it was suggested that you would bifurcate the HTTPS call and have the certificate authenticated independently of the transaction, and now we're looking at things like short-lived certs, potentially leveraging that, or potentially leveraging individual session identification for verification at the CDN layer. So there's differing ways, and these documents are living and breathing to this day, even though they are still our core key functions that we've built the platform on. And I think it's important to emphasize that we're not standing still, and that we also spend an exorbitant amount of time on the finite details to get it right. Logging is one that I can deeply remember. We took a whole 4-hour session of our quarterly on-sites, and what was supposed to be meant to be covering, I believe, closing out the service provisioning, the content management, and the logging specification turned into an hour and a half exactly on how we wanted to configure logging. And while we borrowed quite a lot from existing logs that CDNs currently use today, we did identify areas that where different data points were needed, different values were needed, and kind of justifying that across the board and getting sign-off was really important. And finally, content management. It's something that we get asked about. JT and I were talking last week, and one of the things that came up was someone had asked just in general about how do we manage purging across the board and content and validation across the board. And it was really about finding standards where we can get different CDNs to align to a standard approach, whether it be pattern matching, which is kind of suggested by the CDNI, or looking at regex-based purging and invalidation, and crafting a way that can be communicated up the chain. And also that content management, the scope of that specification, not be limited to just purging, right? We're looking at pre-caching. We're actually working on some upcoming things that I believe we talk about on the next slide that looks at even further ways that we can pre-populate content even further out to the edge. And it's just all tied into the fact that we have these 4 key functions that we're building on top of and expanding on.
Thanks, Eric. JT, are there any questions from the audience on this section?
Actually, there is a question around SSL, and I don't know if you've answered it sufficiently, but the question is very simple, is how does the platform handle customer or content producer SSL certs?
So, Dan, let me jump in and just start with that, and then we can go a bit further. We've actually, through our POCs that we'll get into, we've actually at BAMTECH provided test certificates that we leveraged as part of the POCs. And so those test certificates enabled us to test our entire workflow end-to-end over HTTPS. It was quite useful because on our side, all we had to do was spin up a unique certificate and generate a unique certificate for the CDN itself. And then because we took care of and leveraged the request routing redirect process, we didn't have to worry about the secondary certificate because that was managed by the CDN to the OCN. So on our standpoint, it was pretty much just setting things up like another CDN, like you would with any CDN partner that you might use where it's your own third-party cert. Dan, I don't know if you had any other aspects to add to that.
No. So as Eric mentioned, like the POC, we actually earlier this year, this was announced in CS. Actually, this was end of last year when we performed several POCs. With BAM was actually the major content provider that we used for most of these POCs. And what we wanted to set out and test was we wanted to start with the hardest problem that we saw at the time, which was how to perform delegation of HTTPS content. So we tested that across both live content as well as VOD content. And the delegation method that we used, as mentioned, was HTTP redirect. And when you do that, because as you perform the redirect, you're actually moving to another host name. You're moving to the OCN's host name, and therefore there's no need to actually share secrets and pass secret information from the content provider to the open caching system. So this actually allows a very smooth transition. As Eric mentioned, it was pretty orthogonal to the content provider in this example that this handoff actually took place, and it was a very smooth transition. And we tested this. Request routing was the first interface that we tested during these POCs. So this is how it's done. As Eric also alluded to, when this was with 302 redirect. When using DNS CNAME delegation, there's a method that we've defined in the specification for doing that, and we're also looking at additional work that IETF is doing towards doing that, performing that delegation when DNS is used instead of 302 redirects.
Great, that's all the questions. Yeah, so,
go ahead.
I was just going to say that's all the questions we've got so far. So please continue.
Okay, cool. So this was the POCs that were performed at the end of 16. In this quarter, we're actually looking to do the next generation of POCs. Some of the same involved parties as well as some new ones. Our focus for this next phase of POCs is actually to move from labs to more real-life scenarios with actual live traffic. That is one aspect of testing. And additionally, since during this year we're actually able to complete the architecture and complete the other three interfaces outside of request routing, we are going to test in the field the three other interfaces, which are logging, service provisioning, and content management, and basically create a full end-to-end workflow of open caching. Again, this is going to span both live and VOD and HTTP and HTTPS. So this is the goals for the working group. We're happy to take on board additional participating companies. So if you're listening and your company wishes to participate in these trials, we would be, in most likelihood, happy to accept you and bring you on board.
Yeah, and just to add to what you were saying there, Dan, you know, from a content provider standpoint, if there are content providers that want to provide content, it's a very easy lift to set things up for this. If we're working with one of the partner content delivery networks as kind of the intermediary, there are specialists at each of those CDNs that have been tightly involved with the working group, so they know the necessary configuration requirements that are needed, and then it's simply, you know, either using a test domain that you might already have set up with that CDN or with CDN partners, and then providing content. In the case of at the time when we were part of MLB Advanced Media, we have kind of an active test stream that we were able to leverage for this POC that we use for both internal testing and external testing, and that, you know, as we kind of move to the next level and the next phase, we've identified some of our content that we will be able to test in the wild in a very contained manner that will give us really good insight at different ISP levels and through the standard interfaces with very little change on our side. So it's really a pretty simple amount of work to do as long as you're working with one of those partner CDNs that are currently involved with the open caching working group and the SVA. And if you're not, you can encourage them to support it. That would be great. The more CDNs we have that can kind of interface with it, the easier I know my job will get. So I always appreciate that. Back to you, Dan.
Thanks, Eric. So where we go next as a working group, and I think we kind of mentioned this on a couple of these slides. We're basically, as a group, we're working in two parallel directions. And maybe Eric, you can walk us through the first, and I'll talk a little bit about the second one.
Sure. So, as Dan's kind of mentioning, right, we have now kind of a research and specification group, or rather track, and another track that's focused more on the standardization side. And for the research and specification side, we're really just trying to drill deeper and also revisit existing specifications we've worked on to date. So we're starting with authentication and cores, looking at both cross-origin resource sharing and the way that cores can sometimes become a little bit of a tricky aspect to handling unique pieces of content, especially as a content provider that's trying to reach millions of different users and hundreds of different devices. You don't want to have to replicate and duplicate resources to satisfy cores requirements, but you don't want to break that user experience. So working to solve that type of problem, as well as at the same time token authentication, and looking at ways to tackle what has been a relatively disparate, each CDN doing their own type of thing when it comes to tokenization and security through obscurity on the content side, and seeing different ways we can maybe suggest implementation in addition to the CDNI approach that the IETF has supported. We're also, as we mentioned before, revisiting our request routing spec to look at new things like SSL delegation and how we might handle that, and just seeing if there's other areas that we might want to update as we continue to grow and as that document lives and breathes. We mentioned it before, but kind of getting that storage and that caching even further into the home as part of our some members of our working group, we're focusing now on kind of home caching and edge storage, particularly for video-on-demand content, ways that we can get content already pre-positioned and already available with inside a user's home based on their experience. And then finally, multicast and LTE broadcast, really in an area that partners of ours like Mobilize are really supporting as part of the SVA. Focus on ways that we can optimize and leverage the open caching within cellular networks. Obviously, an area more and more people are viewing and playing content back on, and if there are ways that we can kind of help push some new technology in that environment to benefit both live and on-demand streaming, we're certainly working to do so to improve and reach those goals at the end of the day of improved performance and improved insight. Dan, over to you for the standardization part.
Thanks. Just like a couple of points on research research activities that we're working on. So I think the main goal for us is to actually try to leverage unique assets that the various service providers, both mobile and fixed line, have inside their networks or are actually like in their customer install base. So we're like with home caching, or edge storage that Western Digital, which is another member company in the SVA, are leading. We're looking at ways that devices like residential gateways that are owned by the ISPs can actually leverage storage that they have on board and then use that for streaming of content and leveraging a lot of pre-population of content during off-peak hours. So that's one element. And with multicast, both the multicast ABR format, which is more relevant for fixed line networks, but also LTE broadcast or EMBMS, we're looking at ways that multicast switch is typically a framework that is only available within the ISP network. It's not available when you cross between different networks. How over-the-top content providers can make use of this layer, and open caching as potentially acting like a bridge between that resource and the CDNs and content providers alike. So this is the activities that we've been working on for the last like 2 or 3 months within the working group. And then the other avenue that we've once we've concluded the main architecture for open caching, we've had members that are we still have members that are part of the IETF in general and CDNI working group, and we're now looking to incorporate a lot of the work that we've done over the last 2 years and merge that or add it on top of the CDNI framework. And in the upcoming IETF meeting in Singapore just next month, we're going to have a couple of our members, Sanjay Mishra from Verizon and Ori Finkelman from Qwilt. They're going to present our work and hopefully drive that within the IETF. So that actually creates a more standardized approach to the best practices that we've defined within the SVA. So that pretty much wraps the majority of the topics that Eric and I have prepared in advance. JT, at this time, we would be happy to take any more questions from the audience in the time that we have left.
Absolutely, and that was a fantastic job, guys, and I do have a few questions to ask you. So the first one relates to the POC, and the question is, what kind of results have you seen from the first phase of the POC? What is the impact on latency of using the open caching nodes in an operator network?
So the impact really is relative to the location of the open cache nodes. So we've, like I think in at least one of the test networks where we were deployed, the location was, I think, like 15 milliseconds away from the users. And that's, if you put aside the setup overhead for the actual delegation of content, but once that is done, for the rest of the stream content, that was the latency that was experienced. So like 15 to 20 milliseconds. And you know, ultimately, like, because this was like a very contained test, but what we expect to happen, like in a full network deployment, and you know, Qwilt as a company, we have several of these types of deployments that where the caches are deployed at the deep edge. This is what's to be expected. So sub 20 millisecond to the user, and in many cases, it really depends on the existing state of streaming for that individual content provider, but in many cases the improvement can be can be major. Like it can be like it can shift you by, in some cases, like over 100% in the average bit rates that the users are experiencing.
All right, very interesting. I've got another question here for you. Somebody's asking about the next step for the POC. I know you talked about phase 2, but how do interested companies get involved? Do they reach out to you? Do they reach out to the SVA? What's the process?
I think both options are open. The SVA's website is streamingvideoalliance.org. I think there's a contact form that ultimately ends up on JT's inbox, but both, either that's one option, and then reaching out directly to Eric or I would be another option. Or if you know member companies that are in the SVA, I think just as a general practice, it would be cool to talk to them and get their perspective from the SVA, and then they would be able to make the proper introductions if needed. Fantastic.
And I've got one last question here, and maybe this is a question for Eric. Will the Streaming Video Alliance be developing the APIs and getting them into GitHub or something like that, or is the organization relying on other companies to do that?
You know, I don't think we've figured out yet where we're exactly going to put things. We obviously have been slowly ratifying specifications that are being published on our website. And then, in addition, we have an internal documentation portal where those are going. But I think over time, opening these up and adding them to an environment like a GitHub would make a ton of sense, and just continue kind of our goal of getting this into as many hands as possible to improve the reach and improve the ability of performance. And as Dan mentioned, right, we'll have APIs that'll be part and parcel of this workflow, things for the provisioning specifications and things for the entire request routing and that nature, and that'll all come together at the end of the day to some centralized repository. I guess I would kick that back to you, JT, and also ask the question of, you know, as part of the SVA, is there a specific group that we're going to support in order, and an environment that we might want to place our code on? And maybe I can end there where I'm throwing it back to the panelists for once.
No, that's a great question, and that's something that we have to decide at the board level about how we take open caching to that next phase, which is really beyond specification into, you know, something that's codified. But we'll definitely be exploring that at the next board meeting in November. I did have one last question that came in from the audience, and I want to get to this before we run out of time. The question is, it's really kind of a statement, but it says, I saw already that multicast ABR is starting to be considered, you know, alternatively to open caching or CDN architecture. How do you counter this position with open caching?
So let me take that. I don't think it's an alternative. I think it's completely like a complementary technology. Even if a service provider has a multicast ABR infrastructure in their network, one of the big challenges is how and which content gets into that, into leveraging multicast ABR. And right now, multicast ABR is like in the very few places where it is deployed is primarily and almost solely used for the service provider's own content. So let's say I am ISP X, I can use multicast ABR in my content, but as we all know, there's more than one content source that people are consuming these days. The content sources are nearly infinite. And what open caching enables is to actually open up that resource, the multicast ABR resource, to third-party content. And this can come from anywhere, as long as they will leverage that infrastructure. So multicast ABR, we look at it as almost an optimized delivery by an open cache. So instead of an open cache streaming the content in a unicast fashion, they can do it over multicast.
Yeah, and just to add to that, Dan, you know, I think we pointed out one of the areas we're focusing on is multicache and LTEB, multicast and LTEB, and you know, we've been exploring that as part of it, and I wouldn't be shocked if we'll have some specification of some way in the near future for where open caching and multicast can be leveraged together to improve performance. Because at the end of the day, it's all about improving end performance. It's not about looking at one way or another. If we can marry the two together and find a good way to have open caching deeper inside a network, and then at the same time leverage the multicast technology to have the ISP more intelligently delivered to their end users, but at the same time have that cache closer to them so that their end users have an even better performance. I think we're all for that. I think we're working to find that way with some of the active initiatives we have going on in the group right now.
I did have another question come in. Last one here, I think, before we can cut out, is there going to be a common multicast protocol like OPPM, which stands for Opportunistic Multicast Protocol? Anybody want to address that?
I'm not. So this, I think, is more of like a judgment call. Right now, there's definitely like competing standardization around activity around this area, like Cable Labs and Norm. this is, I think, one of these things that market adoption by vendors and by the service providers will dictate whether we converge on one standard, or there will be like multiple variants by different bodies. Right now, it's still there's no clear winner, and maybe that will be the status of things in 5 years' time. I think it's too early to call.
Yeah, I would concur with that. I would definitely concur with that. I think it's way too early to call.
Fantastic, guys. Listen, this has been a great webinar. I want to thank both of our presenters, Dan and Eric, for taking their time to walk us through open caching, as well as all of our attendees for taking the time out of their day to come listen to this presentation. If you have more questions about open caching, obviously, please reach out to either Dan or Eric. You can also visit the Streaming Video Alliance webpage at streamingvideoalliance.org. There is a section underneath our working groups called Technical Documents, where you can actually find all of the current open caching functional requirements and technical specifications that have been published to date. With that said, I want to wish everybody a wonderful rest of your day, and this will be recorded, so if you have a colleague who didn't get a chance to attend but wants to listen to it, you'll get an email notification about that shortly. Again, thank you very much, and have a wonderful rest of your day. Bye, everybody.